We would like to solve this example, the limit of cosine of 3x minus 1 over x squared as x goes to 0. Whenever we have a limit, the first thing we need to do is to plug in the number that we have in here into our function. So let me plug in 0 in here. What do I get? I get cosine of 3 times 0, which is 0, minus 1 over 0 squared, which is 0. And cosine of 0 is 1 minus 1 over 0. So on top, I have a 0. On the denominator, I have a 0. That's a problem. 0 over 0 is indeterminate, and we need to do something about this. So the first rule, the easiest one that we should use in this case, is the L'Hopital's rule. So I'm gonna erase everything in here, and as a kind of a hint, I'm gonna write I get 0 over 0. Now I'm gonna use a L'Hopital's rule. What is the L'Hopital's rule? L'Hopital's rule is saying that whenever you get 0 over 0 or infinity over infinity, this limit is equal to the limit of derivative of the top over derivative of the bottom. So let me write this. The limit is equal to the limit as x goes to 0 of a fraction. On the numerator, I need to put derivative. So what is derivative of cosine of 3x? Is 3 sine of 3x. And since I have a cosine, I get a negative in here. And then derivative of negative 1 is basically 0. What is the derivative of the denominator? Is 2x. Good. Now, let me plug in 0 again into my function. When I plug in 0 into the numerator, I get negative 3 sine of 3, 0. Let me write this. I get negative 3 sine of 0 over 2 times 0, which is 0. Sine of 0 is 0, and again I get 0 over 0. Okay, so again I have this situation, which is indeterminate. So I'm gonna use L'Hopital's rule one more time, and as a hint, I'm gonna write, okay, I get 0 over 0. I'm gonna use L'Hopital's rule one more time, and I get what? This limit, based on the L'Hopital's rule, is equal to the limit of derivative of top over derivative of the bottom. So derivative of top is negative 3, that's a constant. Derivative of sine of 3x is derivative of inside, which is 3. Derivative of sine is cosine of 3x. That's chain rule. And then derivative of the denominator is 2 as x goes to 0. Okay, so now let me plug in 0 here into the limit to see what I get. So when I plug in 0, I get negative 3 times 3, which is negative 9, cosine of 0. So I get I get what? I get negative 9 cosine of 0 over 2. Cosine of 0 is basically 1. So very good. I get negative 9 over 2. That's the answer for this limit. In this video, we would like to recall L'Hopital's rule and give 2 more examples of the L'Hopital's rule just to have more practice. So let me explain the L'Hopital's rule. L'Hopital's rule, and what is that? L'Hopital's rule says that when we are taking the limit of a fraction f of x over g of x as x goes to a, and if we get 0 over 0, or if we get infinity over infinity, any combinations of positive infinity over positive infinity, or positive infinity over negative infinity, any combinations of infinity over infinity or 0 over 0, then we can say that the limit of f of x over g of x as x goes to a is equal to the limit of derivative of the numerator over derivative of the denominator as x goes to a. Okay, so a here can be any number, or it can be positive or negative infinity. So one more time, if we are taking the limit as x goes to any number or positive or negative infinity of a fraction, and then if we get 0 over 0, infinity over infinity, these cases are indeterminate. So how can we get a number instead of indeterminate? We write this limit as the limit of derivative of top over derivative of bottom, and the answer for this limit is exactly the answer for your question for that. Great, that's L'Hopital's rule. Let's have a couple of examples just to clarify. So just assume that we want to take the limit of sine of x over x as x goes to 0. Okay, so the first thing we need to do in any limit, we need to plug in the point, the number into our function. So I'm gonna plug in here. I get sine of 0 over 0. Sine of 0 is 0, so I get 0 over 0. That's the case in the L'Hopital's rule. So I get 0 over 0. So this limit is equal to the limit of the derivatives. So I'm going to remove this one because it's an indeterminate case, and I'm going to just write 0 over 0 just to remind myself that this is the reason that I'm using L'Hopital's rule. So this would be the limit. Derivative of sine is cosine x. Derivative of derivative of x is just 1, and x goes to 0. I'm just going to repeat the limit in here. So now let me evaluate this limit. So I get cosine of 0 over 1. Cosine of 0 is basically 1. So I get 1 over 1, which is 1. I get a number, and this is not indeterminate. So the answer for this limit based on the L'Hopital's rule is 1. I usually tell my students to write like this abbreviation just to say that we use L'Hopital's rule. So let me solve one more example in the L'Hopital's rule. So example, the limit of e to the x over x squared as x goes to infinity. Okay, as you see here, the number a in the L'Hopital's rule in this example is infinity. But we are going to do the same thing. Basically, we just need to evaluate the integral and take the limit of the numerator as x goes to infinity and take the limit of the denominator. But when I take the limit of the numerator, what do I get? So if you remember, the graph of e to the x looks like this. So this is the graph of e to the x. And as you see, when x goes to infinity, the function goes to infinity. So numerator would be infinity if I evaluate it as x goes to infinity. How about the denominator? When I plug in infinity in here, or basically taking the limit of x squared, the graph of x squared looks like this. X squared. As you see here, when x goes to infinity, the function goes to infinity. Therefore, the limit of the denominator is also infinity. So I get infinity over infinity, one of the cases in L'Hopital's rule. It's indeterminate, and I can use L'Hopital's rule. So let me erase this part. And then I'm gonna say that I'm using L'Hopital's rule because I get infinity over infinity, and I'm gonna write the limit of, based on the L'Hopital's rule, I'm gonna get derivative of the numerator over derivative of the denominator. Derivative of the numerator is e to the x. How about the denominator is 2x as x goes to infinity. And now I need to evaluate one more time. The limit of e to the x, we did it before, is infinity, and the limit of 2x when x goes to infinity, look at the graph of 2x is a line like this, y equals to 2x, and as x goes to infinity, this graph goes to infinity. So I get infinity over infinity. Therefore, it's indeterminate, one of the cases of L'Hopital's rule. So I need to use L'Hopital's rule one more time. So L'Hopital's rule one more time, and then I get the limit, derivative of the numerator e to the x, derivative of the denominator is just 2 as x goes to infinity. Now evaluate it one more time. The limit of the e to the x is infinity, and the limit of 2 as x goes to infinity, the function 2 looks like this. Is a constant function, y equals to 2. As you see, when x goes to infinity, it is always 2. So I get infinity over 2, and as you know, infinity over 2 is basically infinity. Or basically, when you divide infinity by any number, you get infinity. It's not indeterminate, it's infinity. The limit does not exist, but it's determined, it's infinity. So we solve this example using L'Hopital's rule.